Part 1, Introduction of KUKA Robot. The model of KUKA robot that we use in the lab is KR16. The number 16 indicates that the robot can withstand a maximum load of 16 kilograms. There are many functions of an industrial robot. For example, the KUKA robot can be used in material handling, palletizing, painting, welding and many more. KUKA robot has a total of 6 axes, where each of them is powered by an individual motor. This is axis 1, which is responsible for the 180-degree rotation of base from left to right. Axis 2, the joint connecting the base and arm linkage, it is responsible for the motion of the linkage. Axis 3 enables the robot arm to raise and lower its position. Axis 4 helps to rotate the robot arm in circular motion. Axis 5 allows the armrest to move up and down. Axis 6 provides rotational motion of the tools. Part 2, How to switch on the robot. Step 1, turn on the power supply. The power supply is a 3-phase AC voltage, which gives out 415 volt to the robot. Step 2, turn on the voltage stabilizer. The purpose is to stabilize the fluctuating voltage. Step 3, switch on the air dryer. Its function is to remove the air moisture. Step 4, turn on the air supply. Step 5, adjust the effector until no air leakage sound is heard. In KUKA robot, it has an emergency mechanism, whereby the effector will be automatically detached when it encounters impact force. To attach the effector back, align the marks which are the small line and hole as shown in the video. Step 6, turn on the CPU of robot to activate the control panel. Inside the CPU, it consists of the driver of 6 motors, the connection of input, output devices and backup battery to prevent data loss. The KUKA Control Panel, KCP. KCP is the teach pendant to control and program the KUKA robot. In this lab, we have learned the functions of some buttons. The explanation is given according to the labeled number. Number 1, the space mouse. It is used to control the robot in the mouse mode. Number 2, the status key. It is also used to control the robot motion. The plus and minus signs represent the motion in opposite direction. Number 3, 4, 5 and 6, return key, cursor block, keypad and numeric keypad. Their function is same as the key that we use on computer keyboard. Number 7, 8, and 9. These are the soft keys and menu keys that used to select the options from the panel window. Number 10, 11 and 12 are the start backward key, start forward key and stop keys respectively. These keys will be used when running the KUKA robot. Number 13 and 14 is the window selection key and escape key. The rear view of KCP. The 3 white buttons are the enabling keys of the robot. Either one must be pressed and hold in order to move the robot. The green button is the start key. It is pressed when we want to run the robot automatically. Part 4, the panel window. When this button is selected, the robot is controlled using the status keys. When this icon is chosen, the robot now controlled by mouse. Pressing this icon will activate the gripper motion. This is the setting of robot travel speed, which can be set to 100%, 75%, 50% and 25%. For this section, it limits the travel distance of robot for certain angles. This is the speed setting when running the robot in manual mode. This is the message window, which provide users the necessary information. This icon indicates the coordinate system used in robot motion. Exercise 1, Jogging of KUKA robot. The robot can operate in different coordinate systems. First, the axis-specific motion. In this system, the robot can move individually in specific axis for the positive or negative direction. To move the robot, enabling key is first pressed. Then, the eye icon will change from red to green. The robot is moved using the status key. This is the same for other coordinate systems. Second, the world coordinate system. In this system, the origin is located at the base of robot. The robot can move linearly in X, Y, Z axis. The A, B, C axis responsible for rotational motion of the robot wrist. Third, the base coordinate system. The origin is located on the workpiece that is to be processed. The last system is known as tool coordinate system. The difference is that the origin is now located on the tool. When the tool orientation is changed, notice that the motion using the same axis will be different as well. Therefore, the multiple coordinate systems can be used in order to perform different tasks, which increase the flexibility of the robot motion. Exercise 2, Programming the KUKA robot. Before starting to program the KUKA robot, a directory folder named C is created. Click Open and create a file named Trial. This file will be used for programming. The first 2 lines will allow the robot to move back to its home position. To set the position for the next movement, point-to-point method is used. After moving the robot to a desired location, press. Close the program and open it again,